8 wants me to work with the graph of a fraction. The first thing part 8 wants to do in part 8 is to find the domain of the fraction. And to find the domain of any fraction, you ignore the numerator and set the denominator equal to 0. The algebra to find the domain gives me x equal to 3. When I go to write my answer to part A, I can say the domain of the fraction f of x equals 2x plus 6 over x minus 3 is all real numbers except x equal to 3. A lot of times I skip writing this part, and I might just say the domain is all real numbers except x equal to 3. Those are both correct answers. If you don't want to get as wordy as I did, that's completely fine. Part B wants me to find the vertical asymptote. The algebra to find the domain gives me the equation of the vertical asymptote. The vertical asymptote is going to be at x equal to 3. I'm going to graph that on my graph. So I'm going to draw a vertical line that goes through 3 on the x-axis. When you're presented with your test question, you're going to have a blank graph just like all of my problems are going to have a blank graph that I need to graph. And it's going to have numbers on the x and the y-axis that tell me the window. So my window should be x min is negative 12, x max is 12, y min is negative 14, y max is 14. The next part is my horizontal asymptote. There won't be any slant asymptotes on the test. So for part C, as I go to find the horizontal asymptote, I look at the highest power term in the numerator, which is a 2x, and I look at the highest power x term in the denominator, which is a 1x. Remember that when there's a tie between the highest exponent in the numerator and the highest exponent in the denominator, you get the horizontal asymptote by dividing the numbers in front of those x terms. So my horizontal asymptote is going to have the equation y equals 2 over 1. I divide the numbers in front of the x's because they have a tie in their exponent, and that reduces to 2. My answer to part C, there's going to be a horizontal asymptote at y equal to 2. I'm going to take that and draw a horizontal line through 2 on the y-axis. Call that my horizontal asymptote at y equal to 2. Part D wants me to find the x-intercepts of that function. The easiest way to find an x-intercept is just to take the numerator and set it equal to 0. So I'm going to set 2x plus 6 equal to 0. I'm going to minus 6 from both sides and get 2x equal to negative 6. Then I'm going to divide both sides by 2 and get x equal to negative 6 over 2. That will give me x equal to negative 3. The answer to part D, the x-intercept is the point negative 3, 0. I'm going to take that point and plot it on my graph, but I won't write it what it is because it makes the graph ugly sometimes when I do that. Part E wants me to find the y-intercept. I'm going to find the y-intercept by plugging in zeros for these x's. So when I go to do part E, the y-intercept, I'm going to go f of 0 equals 2 times 0 plus 6 over 0 minus 3. The pieces with the zeros go away, so you get 6 over minus 3, which is minus 2. The answer to part E, the y-intercept, is going to be the point 0, negative 2. I'm going to plot that on the y-axis by just making a dot at negative 2 on the y-axis. Part F wants me to sketch a graph. So I have everything done from A through E that I can do. I don't really need to look at this anymore because I have everything drawn on the graph. To get my graph nicely, I'm going to get the window set up that's implied here. So the window that's implied is negative to 12 for x min and x max, and negative 14 to 14 for y min and y max. There are other windows that produce a decent graph. This is just the one I came up with. I'm going to enter the function parentheses 2x plus 6 divided by parentheses x minus 3. And for the y-intercept, I can just enter the function 2. For the x-intercept, I'm going to enter 1,000 times the denominator x minus 3 because that produced the x-intercept of 3. Now when I graph this, I'm going to get something that I'm just going to copy onto my work here. It's going to draw the asymptotes in for me, so it's really nice. The upper right-hand corner doesn't need to go through any points, so I'm just going to draw a little swoosh here. And then the bottom left-hand corner needs to go through the x and the y-intercept It needs to get close to that vertical asymptote, and it needs the horizontal asymptote and get close to this vertical asymptote. So the thing that I'm drawing is really a pretty weak drawing, but it has the parts drawn in and it goes towards the asymptotes the way it needs to. The only thing you have to make sure is that the graph looks reasonably the same and that it goes through any intercepts that you've already created. All right, on to number 9. Number 9 has the same parts. So for 9a, I'm going to find the domain. And to find the domain of any fraction, it's enough just to set the denominator equal to 0. When I set this equal to 0, I'm going to factor. And the numbers I'm going to exclude from the domain are -5 and +2. I'm going to say the domain. And I'll do the shorter version of the answer. Is all real numbers. I forgot the word is. Is all real numbers except x equal to -5 and x equal to 2. Part B wants the vertical asymptote, and for us that just comes right from the domain. The vertical asymptotes are going to be x equal to -5 and x equal to 2. Let me put these on my graph before I forget to do them. So draw a vertical line through -5 on the x-axis and a vertical line through 2 on the x-axis. Done with that. Moving on to the horizontal asymptote. For the horizontal asymptote, which is part C, I look at the term in the numerator with the highest exponent and the term in the denominator with the highest exponent. The term in the numerator with the highest exponent has a highest exponent of 1, and the denominator has a highest exponent of 2. The highest exponent in the numerator is less than the highest exponent in the denominator. Then the x-axis, which has the equation y equal to 0, is a horizontal asymptote. So for an answer for part C, the horizontal asymptote is going to be y equal to 0, and there's no work to do for it. But I need to draw it, which I'm going to put a line through the x-axis. So my horizontal asymptote has the equation y equal to 0. Alright, so now I'm moving on to finding the x-intercepts in part D, then the y-intercepts in part E. For part D of number 9, to do the x-intercepts, I'm just going to take the numerator and set it equal to 0. That's going to give me x equal to 1. My answer to part D should be the point 1, 0. It's right on a horizontal asymptote. It's okay to cross a horizontal asymptote, but you usually would cross it by the origin. For part E, I need to find the y-intercept. And let me just do that on another sheet of paper because it's getting so messy here. So for part 9E, for the y-intercept, I'm just going to plug in 0 for all my x's. So I'm going to get f of 0 equals 0 minus 1 over 0 squared plus 3 times 0 minus 10. All the pieces with 0 turn into 0. You're left with minus 1 over minus 10, which is positive 1/10. The answer to part 9E, the y-intercept is going to be the point 0, 1/10. I'm going to plot that on my graph, and it's going to be just right above the origin. So it's just going to be barely above the origin. So I have my asymptotes plotted, my y horizontal asymptote, and my intercepts plotted. To graph everything, graphing the function's not that interesting. That's easy to graph. But my vertical asymptotes, for that vertical asymptote, I'm going to type in 1,000 times x plus 5 for one of my functions. I'll probably do that as y2. For the vertical asymptote at 2, I'm going to type 1,000 times x minus 2. For the horizontal asymptote at 0, the y-axis is already going to be drawn. I don't need to do anything for it. And then I'm going to enter that as my function and make my window okay. So as I go to finish this problem up, which is just sketching a graph, I'm going to make my window the appropriate window, which is -9 to 9 on the x's, -3 to 3 on the y's. Again, those are just numbers that are given to me. And then I'm going to clear out all the stuff that's already in here and enter the function in y1, which is x minus 1 in parentheses, divided by x squared plus 3x minus 10, both the numerator and the denominator in a parentheses, and then get my vertical asymptotes by doing 1,000 times x plus 5 and 1,000 times x minus 2. Hit graph and just copy now. The bottom left doesn't have any intercepts to go through, so I'm just going to draw what it looks like. The middle needs to go through the x and the y-intercept, and it needs to kind of have that same kind of, I don't know if that's an S or a backwards S shape. And the upper right can't cross the x-axis because there's no intercept, so it's just kind of up like that. Probably gets a little bit closer to these asymptotes than I've drawn, but this is accurate enough. So I just took the three pieces, the three panels in between the vertical asymptotes and on either side of the vertical asymptote, and copied something that looked reasonably similar to the graph. The rest of the problems come from section 5.6. To find out where the graphs are greater than or less than or equal to 0, we start off by plotting negative infinity, positive infinity on the x-axis, plus the x-coordinate of any x-intercept and the x-coordinate of any vertical asymptote. There's a vertical asymptote at -4. If the problem has an or equal to, then vertical asymptotes get round brackets, x-intercepts get square brackets. When I go to create intervals, I'm going to create an interval from negative infinity to -4, an interval from -4 to +3, x-intercept gets a square bracket, vertical asymptotes get round brackets when there's an or equal to, and then 3 to infinity. For each of these intervals, I just need to figure out if the graph is above or beneath the x-axis. In the interval that corresponds to negative infinity to -4, the graph is above the x-axis, so that will be part of 10a. So in 10a, I'll put the interval from negative infinity to -4, double round brackets. The portion of the graph that corresponds to -4 to +3 is beneath the x-axis, and that's going to go in part b because the y's are negative. That's a round parentheses on -4, square parentheses on 3. And the last interval corresponds to that part of the graph which is above the x-axis, and that's going to be in part A then, because part A needs the regions above the x-axis. For question 11, because the initial problem doesn't have an or equal to for either the greater than or the less than, every point's going to get a round parentheses when I create an interval. So on my x-axis, I'm going to put the x-coordinates of the x-intercepts along with negative and positive infinity and create intervals, all round parentheses because there's no or equal to. So negative infinity to -4, -4 to 3, 3 to 6, and 6 to infinity. And then for each interval, I need to figure out if the graph is above or beneath the x-axis. If it's above the x-axis, it goes in part A. If it's beneath, it goes in part B. The first interval corresponds to that portion of the graph. It's beneath the x-axis, so the y's are less than 0, and it goes in part B. The middle interval corresponds to the portion of the graph above the x-axis. The y's are positive, so it goes in part A. The third interval corresponds to that region. The graph is beneath the x-axis, so it goes in part B. And the last interval corresponds to that. It's above the x-axis, so the answer goes in part A. The last few problems are just doing this graphically, or doing it without a graph and creating the graph. So for question 12, to solve the same question when you're not given a function, you have to find any x-intercept, the x-coordinate of the x-intercept, and the x value for any vertical asymptote. There's no vertical asymptote because this isn't a fraction, so I better find the x-intercepts and get the x's part of the x-intercepts plotted on a y-axis. To find the x-intercepts, I'm going to take the function and set it equal to 0. I'm going to factor into x plus 7 times x minus 1. And then I'm going to take and split the factors and set them equal to 0. So on my x-axis, I'm going to put -7, +1, along with negative and positive infinity. I'm going to create intervals Because of the or equal to, the x-intercepts will get square brackets. The intervals are going to be negative infinity to negative 7, negative 7 to positive 1, positive 1 to infinity. I'm going to graph this with a zoom standard and just throw the graph onto it to answer my question. So I'm going to go y equals clear, 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 and enter x squared plus 6x minus 7, zoom standard. And it's a parabola. If it bugs you that you can't see the bottom of the parabola, change the y min and make it a smaller number, like maybe negative 20, and you'll be able to see the whole parabola. Here's the vertex, the x-intercept at negative 7. There's the x-intercept at 1. I'm just basically going to copy this through. I don't really care where the vertex is at. So I'm making a really crude graph, and now I'm going to answer the question. The first region of the graph corresponds to that interval. The graph is above the x-axis, so that's going to be part of 12a. So the interval from negative infinity to negative 7, the y's are positive. The middle interval corresponds to that part of the graph which is beneath the x-axis. That's going to be in part b, where the f of x's or the y's are negative. The last portion of the graph corresponds to that interval. The y's are positive, so it's going to be in part 12a. So I'm just looking above and below the x-axis once I have the graph. For question 13, because it's a fraction, I need to find the x-coordinate of any x-intercepts and the x-coordinate of any vertical asymptote. To find the x-coordinate of the x-intercept, I set the numerator equal to 0 and get x equal to negative 3. To find the vertical asymptote, I set the denominator equal to 0 and get x equal to 4. I'm going to create a graph. On my graph, on the x-axis, I'm going to mark negative 3. On the y-axis, I'm going to mark 4. And I'm going to create intervals after I get the infinities on my axis. The problem has an or equal to, so x-intercepts get square brackets, vertical asymptotes get round brackets. The first interval I'm going to get is negative infinity to negative 3. X-intercepts get square brackets, that's an x-intercept, so I'll square bracket it. The middle interval is going to be negative 3 to 1, negative 3 to 4. X-intercept square bracket, vertical asymptote round bracket. Last interval, 4 to infinity. Vertical asymptote round bracket, infinity round bracket. Now I'm going to enter this function with a zoom standard. So y equals clear x plus 3 divided by x minus 4, putting the whole numerator and the denominator in a parentheses. So hard to get these to not blur out. And so window zoom standard. And draw that asymptote, please. Oh, I didn't do the asymptote. So y equals 1,000 times x minus 4. We'll get that asymptote drawn in. I just didn't even think to draw it. Now the asymptote. So this portion is up here. It's all above the x-axis. The graph is going to cross the x-axis and not reflect off of it because it has odd multiplicity. So the graph really does something like this for this half. If you want to see better what's happening by that x-intercept of negative 3, make your window really small. Make the y's maybe negative 1 to 1. You'll lose this portion of the graph, but you'll see better that the graph crosses at that x-intercept. So now for each interval, I'll describe what it does. The portion of the graph that corresponds to negative infinity to negative 3 is above the x-axis, so that's going to go in part A. So for 13a, I'm going to include the interval from negative infinity to negative 3. The portion of the graph that corresponds to negative 3 to 4 is below the x-axis. That's going to go in part B. And the portion of the graph that corresponds to 4 to infinity is above the x-axis, so it's going to go in part A. So my answer to part A is going to have the interval from negative infinity to negative 3, square bracket on the negative 3, and 4 to infinity, round bracket on the infinity. Part B, square bracket on the negative 3 to round bracket on the 4. 14 and 15 don't have or equal to, so I'm going to get all round brackets. I need to get the x-intercepts. I don't care to do this by hand. Let me try to get them from my calculator. So I'm going to enter this function, x up arrow 3 plus 6x squared minus 27x, graph it, and the graph has 1, 2, I can't even see the x-intercepts so well. So let me try to find these x-intercepts real quickly by going second, table, any number in the x column that has a 0 next to it in the y column is an x-intercept. So there's one x-intercept. Its x coordinate is 0. I just need the x part. I don't need the y part. There's a second x-intercept, has an x coordinate of 3. I don't need the y part. And I'm not seeing any more x-intercepts, so I think that's all the x-intercepts there are. Let me make my window handle this, because my window needs to be way higher to see what's going on here. So let me do my window and make it way, way bigger on the y's. Oh, because it was only on the 1s. How about negative 20 to 20? I don't know what's going to happen there. I'm missing an x-intercept. Second table. Maybe I just didn't go far enough back. Oh yeah, I missed that one at negative 9. Ha ha. When I looked at the graph, it crossed the x-axis 1, 2, 3 times, but I only had 2 x-intercepts, so it told me I didn't look far enough in my table, so I peeked and went further back in my table. Still, my window's not so great. Let me make these y's really extreme, maybe negative 50 to 50. I still can't see it. I've probably got to get up to 100 maybe even. How about negative 50 to 100? Still not high enough. I'm not going any higher. I'm going to sketch this graph, and on my x-axis, write these x-coordinates of the x-intercepts of negative 9, 0, and 3. Create intervals. This first interval, I don't have the infinity there, but it's going to be negative infinity to negative 9, all round brackets because there's nowhere equal to. The middle interval is going to be negative 9 to 0, and then 0 to 3. The last interval is going to be 3 to infinity. Copy this graph. I don't know how high it goes, but I finally couldn't get there. So this graph was going to do something like this. Goes through the x-intercept, goes up to a turning point, crosses the x-axis at 0, goes to a turning point, crosses the x-axis at 3. So you can kind of copy the graph reasonably well. And now I'm going to go to answer this. The first region corresponds to a portion of the graph beneath the x-axis, so that goes in part B. The second region corresponds to that part, which is above the x-axis, so that goes in part A. The third region corresponds to a part below the x-axis, so that goes in part B. The fourth region's above the x-axis, so that's in part A. So for me, these are such easy problems, because I can obviously look at a graph and tell above and below the x-axis and just have to target the intervals. Last problem on the review. I need to find the x-intercepts and the vertical asymptote because it's a fraction. To find the x-intercept, I set the numerator equal to 0. To find the vertical asymptote, I set the denominator equal to 0. Because there's a square, I have to factor. And I'm going to get x equal to positive and negative 3. So on my graph, I need to put negative 3, positive 1, positive 3. The infinities might be nice. Create intervals, all round brackets because there's nowhere equal to. So negative infinity to negative 3, negative 3 to positive 1, positive 1 to 3, positive 3 to infinity. I'm going to zoom standard this graph. I'm going to enter the vertical asymptotes by doing 1,000 times x plus 3 and 1,000 times x minus 3 because I like seeing those vertical asymptotes. So I'm going to enter this function y equals clear parentheses x minus 1 divided by parentheses x squared minus 9, and then do 1,000 times x plus 3 for one of the vertical asymptotes and 1,000 times x minus 3 for the other. Zoom standard, which might not be the best window, but it's a good starting point. I can kind of tell what's going on now. And the I didn't draw my asymptotes in here. Let me draw these asymptotes in at negative 3 and at 3. In the first portion of the graph, it's all beneath the x-axis. It can't cross the x-axis because there's not an x-intercept. In the middle portion of the graph, it snakes and crosses the x-axis because there's an x-intercept. And the upper right-hand portion, it looks like that. If you want to, crunch the windows way down on the y's, maybe like from negative 3 to 3, and you might see a graph that's easier to notice what it's doing. So whatever you need to do to play with your window to get the graph, you can. either making the y's bigger or smaller. It's not really making anything with the x's. And now to go to do my answer, there's going to be an answer for 15a for the regions that are above the x-axis, 15b for the regions below. The first interval is below the x-axis, so I'm going to put that in part B. The second interval is this interval above the x-axis. I'm going to put that in part A. The third interval is this region below the x-axis. I'm going to put it in part B. And the last interval is this region above the x-axis. I'm going to put it in part A. So that's everything for the review. As always, if you can do every problem on the review, you should be able to do every problem on the test. So just perfect these 15 problems and you should be completely fine for the test.